All around us, there's this quiet revolution happening. Billions, and I mean billions, of everyday objects are coming online, creating this massive, invisible network that's changing pretty much everything. So today, we're going to pull back the curtain on one of the key technologies making it all possible, LoRaWAN. Just to give you a sense of the scale we're talking about, look at this number. This was Gartner's estimate way back in 2018 for how many connected devices there would be by 2020. Over 20 billion. That's almost 3 devices for every single person on Earth. And this absolute explosion of things created a huge connectivity problem, a problem our usual tech just wasn't built to solve. Now, this is all part of that grand vision we call the Internet of Things, or IoT. And the idea is actually pretty simple, but it's incredibly powerful. Imagine a world where all these everyday objects, from a tiny sensor in a farmer's field checking soil moisture to the streetlights and trash cans in our cities, are all smart, all connected, and all sharing data to make our world run better. And that right there is the million-dollar question. I mean, how do you actually connect billions of tiny, cheap devices that have to run on a battery? A battery that, by the way, needs to last for years without anyone touching it, often in the middle of nowhere. That is a very specific and a very tough problem. You see, the technologies we know and love, the ones we use on our phones and laptops every single day, like Wi-Fi and our cellular data, they're just not the right tools for this job, not even close. They're built for speed, for streaming video, and all that speed comes at a cost. And for a tiny little sensor, that cost is power. And power is everything. This really gets to the heart of it all. It's a trade-off. On one side, you've got your Wi-Fi and cellular. Fantastic for high bandwidth stuff, but they are power hungry. A small sensor running on Wi-Fi, it might last a few days, maybe even just a few hours. But then, on the other side, you have LoRaWAN. It's like the polar opposite. It's designed specifically for sending tiny little packets of data over crazy long distances, all while sipping power. It fills this massive, critical gap in the market. So, how in the world does it pull off this magic trick of being both long-range and low power? Well, to get that, we need to zoom in a bit on the core technology, starting with the actual radio signal itself, which is called LoRa. Okay, so think of LoRa as the foundation. It's not the whole building, just the rock-solid ground it's built on. It's the really clever way the radio signal is sent out. It uses this method called spread spectrum, which, in simple terms, lets a very, very weak signal be heard and understood even from miles away and through walls and obstacles. It's the physical radio wave doing all that heavy lifting. Now, here's the secret sauce. It's a concept called spreading factor. The best way to think about this is shouting versus talking, right? If you're standing right next to someone, you can talk really fast and they'll get every word. But if they're all the way across a field, what do? You shout, slowly and clearly. That's spreading factor. A low SF is talking fast up close, a high SF is shouting slowly to be heard from really far away. And this isn't just an analogy. You can see how real it is right here. Look at the time on air it takes to send just a single byte of data. With SF7, the fastest rate, it's about 26 milliseconds. Quick. But crank it up to SF12 for maximum range, and it takes over 800 milliseconds. That's more than 30 times longer to say the exact same thing. But that extra time is precisely what allows the signal to be picked up by a gateway that's kilometers away. Okay, so we've got LoRa, this incredible long-range signal. But a signal by itself isn't a network, not at all. You need rules, you need security, you need a whole structure to manage millions of devices trying to talk. And that is where LoRaWAN comes in. It's so important to get this distinction right, because people mix them up all the time. LoRa is the physical radio signal, the shout. LoRaWAN is the network protocol that sits on top of it. It's the whole system of roads and traffic laws. LoRaWAN defines the architecture, manages how devices get on the network, secures all the communication, and makes sure your data actually gets to where it's supposed to go. So let's follow a piece of data on its journey. It all starts with the end device, our little sensor out in the world. It sends out a tiny LoRa signal. That signal is picked up by one or maybe several gateways. Now, the gateway is just a simple bridge. Its only job is to hear that LoRa signal and forward the raw data to the internet. From there, it hits the network server. This is the brain of the whole operation. It manages everything and then routes the message to its final destination, the application server, which holds the keys to finally decrypt that data and show it to you on a dashboard. And of course, you've got to be thinking about security, right? Well, it's baked in from the very beginning. Your data is encrypted the moment it leaves the sensor and can only be decrypted by your application. That means even the person running the network can't snoop on your data. The network also checks to make sure every single device is who it says it is so no imposters can join. And it has this clever system to stop hackers from capturing and resending old messages, making the whole thing really robust.
All right, so that's the tech. It's pretty cool, but what does it actually let us do? Let's zoom back out and look at the real-world impact this technology is already having right now.
The applications are just incredibly diverse because the problem it solves is so fundamental. In agriculture, you can sprinkle sensors across massive fields to know exactly when and where to water. In smart cities, you can know instantly when a parking spot opens up or a trash can is full. In factories, you can track valuable assets across huge warehouses. Basically, anything that needs a small, occasional update over a really long distance is a perfect fit.
And what's also amazing is the flexibility you have. You can tap into a public, community-run network, you could pay a subscription to a big commercial company, or, and this is really cool, if you're a business or even just a hobbyist in your garage, you can buy your own gateway, set up your own server, and build a completely private network just for you.
So if you remember nothing else from all this, just remember these three things. 1. LoRaWAN gives you incredibly long range. We're talking kilometers. 2. It has extremely low power consumption, so batteries can last for years. And 3, it's low cost because the devices are simple and it uses radio frequencies that are free for anyone to use. When you put that unique combination of range, power, and cost together, it just opens up a whole world of possibilities that simply didn't exist before. Which really leaves us with one final and I think most important question. The tools to connect our physical world to the digital one in this super efficient way are here. They're available to everyone. The technology is no longer the barrier. The only real limit now is our imagination. So, what problems are you going to solve? Thanks for tuning in.